Well, all right, Fred, let's light this candle. This is another episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And I am your host for this American summer, Australian winter, Heidi Campo, and joining us is Professor Fred Watson, astronomer at large. Hey, Fred.
Good to see you, Heidi. I can't remember which astronaut that "light this candle" quotes come from. Do you remember which one it was? It was one of the early days of spaceflight, I think.
Definitely early days, and
Yeah.
you're testing my history, and I am failing.
It's all right.
Fred
would
and I,
fail.
we discovered a new feature. So our recording software is updated, and now it does a very exciting countdown for us. So that was that was kind of fun, a way to launch into the episode, so to speak.
Yep. we lit the candle. That's the main thing.
We did,
Yeah.
and so let's set this off. So our destination today for this first episode is we're going on a mission to some of the outer planets. Do we call well, Titan's not a planet, but it's a moon around Saturn. Saturn is a outer planet.
Yeah, that's right. It's one of the four gas giants in the solar system. The second one out. For many, many centuries, it was thought to be the edge of the sun's family of planets, even before the sun was known to be at the center, because it's the furthest of the naked eye planets, the ones that you can see with the unaided eye. Uranus just makes it actually into the unaided eye category, but you really need to know what you're looking at, and you need good eyesight and a dark sight. I've never seen Uranus with my unaided eye. Anyway, Saturn out there, 1.5 billion kilometers from the sun, doing its thing. And of course, from 2004 to 2017, Saturn was the star of the Cassini show. The Cassini mission, I think, one of the most productive space missions ever. NASA, with an association with ESA, the European Space Agency, this fabulous mission. The spacecraft was in orbit around Saturn for 13 years, doing marvelous things before it eventually dived into the Saturnian atmosphere. And I think some of the most exciting stuff, it's actually hard to pick what was the most exciting stuff to come out of the Cassini mission. The rings, the moons, the planet itself. But for my money, Titan really stole the show. With it, actually, I should say, with Enceladus as a close second. Enceladus was where we discovered geysers of ice coming out of the subsurface ocean. But Titan, such a weird world, and we knew it was weird before Cassini got there, because there was evidence from radar measurements from Earth that there was very smooth surfaces on Titan, and it was suspected that Titan would have lakes and seas, not of liquid water, because the temperature out there is about minus 190. That's the surface temperature, 190 Celsius. Sorry, I should specify the unit, shouldn't I? Indeed, it is known to have lakes and seas of liquid natural gas, ethane and methane, which are predominantly in the northern hemisphere. One of the other things that was an early discovery about Titan, and this kind of links to the story that we've got at the moment, was that the surface of the planet is decoupled from the interior. By that, I mean that the rocky core of Titan rotates in a certain way, but the surface actually swishes around a bit. And
You're kidding me.
That's the conclusive proof that you've got a global ocean underneath the surface. It's a liquid interface between the surface and the rock. But if you're on Titan, your longitude changes without you moving, because the surface of the ice moon is moving.
So it's basically just a giant, what do they call those? The little magic balls that you shake up, and it's got the little globe inside that rotates and
Yeah,
tells
that's
you your
right.
future. It's just a
Yeah,
giant.
I haven't seen one of those, but
I can't remember what
sounds
they're
like
called.
what
The
it
little, the magic. I think it's just the magic ball. Yeah. Oh wow, I didn't know that. That's such a incredible fact. So
It
it's not
is.
frozen then.
That the ocean's not. No, that's right. The surface is. And we don't know how thick the ice layer of Titan's surface is. It's probably many tens of kilometers. But underneath that, I mean, Titan is a big world. It's bigger than the planet Mercury. It's the second biggest satellite in the solar system. And so a significant rocky core, and this ocean, which, I don't think we've got any real estimates of what its depth is, but it's, again, measured in tens or perhaps even, tens of kilometers is probably the best guess for something like that, maybe even hundreds. Anyway, the reason why this links to the present story is that there's been a new analysis of the spinning of Titan and its atmosphere. Titan has a thick atmosphere. It's 50% higher atmospheric pressure than we have here on Earth. So we probably feel like we were. I read yesterday that we'd feel as though we were in a depth of 5 meters. 5 meters of water. What's that? 6 meters is 20 feet. So you've
so an average Houston summer.
Yeah, probably. Yes, that's probably right. So it's got this high pressure atmosphere, mostly nitrogen and methane, and they have clouds and rain and of liquid natural gas. It's a bizarre sort of parallel with the Earth, where water is the Earth's climatic cycle. We think it's methane and ethane on Titan, but the atmosphere has now been shown to circulate around Titan, not in sync with the surface like our atmosphere is, because we stand on the surface and we don't feel any wind because the atmosphere is moving with the rotation of the Earth. The atmosphere rotates faster than Titan does. So it's decoupled from the surface, which is a very strange phenomenon in itself. I might give a quote. Actually, this story is actually the one I've read is on space.com. It's an article written by Victoria Corliss, very nicely done. So it's basically data from the Cassini mission, reanalyzing it. And Lucy Wright, who's the lead author, not the lead order, the lead author of the new research, and is at the School of Earth Sciences at the University of Bristol in the UK. Lucy said, the behavior of Titan's atmosphere tilt is very strange. We think some event in the past may have knocked the atmosphere off its spin axis, causing it to wobble. So not only does it not rotate in sync with the surface, but it also wobbles. Basically, that's the best guess, that it was some sort of impact or some event in the atmospheric history of Titan that's caused not just this out of sync rotation, but also a tilt, a wobble of the atmosphere.
That's incredible.
It is.
If I was Andrew and I had the soundboard, I would insert the little jingle from the X-Files right there. Do 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 do.
Yeah, well, that's right. Well, yes,
very strange.
Yes, he sometimes does that. Yeah, we managed to keep him under control, though. That's all right. But yes, it is. It's weird, and it's an extensive study. Perhaps one of the consequences of this, though, is if the atmosphere's not moving in sync with the surface, then it means you've got high winds on the surface. You're going to experience high winds. And that has not really been deduced before, although there is evidence of wind ripples on these lakes and seas. The radar reflections sometimes get very bright, which means you've got radar bouncing off a rough surface. If you get a very faint radar reflection, you're looking at a smooth surface because most of the radar has been reflected off in a different direction. It's like a mirror surface that will give a very dark radar reflection. So a bright radar reflection corresponds to a rough surface, and that has been seen on some of the lakes and seas of Titan. So maybe that itself was a hint that the winds are blowing more quickly than we thought. But what's really at stake here, and this brings us back to NASA, The Dragonfly mission, which is a quadcopter that is planned for exploration of Saturn's moon Titan sometime in the next decade, sometime in the 2030s. That is going to be a bit like Ingenuity was with Perseverance. It's going to be a fantastic tool for exploring Titan, for exploring its surface, for investigating maybe what these seas look like. I don't know whether Dragonfly will dip its toes in the water, but it's going to tell us a lot more than we know already. But here's the problem. If we've got much faster winds than we thought we had, when you're launching a quadcopter into that atmosphere, then that could give us all kinds of problems for the navigation of the Dragonfly drone, which might lead to difficulties in actually making the mission succeed in all its goals. You could argue the same thing with Mars. We know that we get high winds on Mars, and that's what causes the dust storms. Ingenuity managed to cope with that. But remember, the atmosphere on Mars is only, it's less than 1% of the atmospheric pressure on Earth. Whereas here we're talking about an atmosphere that's 50% thicker than the Earth's atmosphere. So there's probably more at stake, I think.
Yeah, it was almost, you almost need to look at more, I'm not an engineer or rocket scientist by a long shot, far from it, but it almost seems like you would need to look at more amphibious designs than aerospace designs, and it would need to be able to navigate in that thick atmosphere, almost like a submarine in the air.
Well, that's right.
Thinking of a Zeppelin.
Yes, a submersible Zeppelin. That's what you need. I mean, something like a Zeppelin will get blown around even more because they've got such a big surface area. But your thinking's right, Heidi, because back in the early 2000s, when we were first discovering this extraordinary surface landscape on Titan, with a surface that's made of ice as hard as rock, but in that rock there are depressions that have these seas and lakes. When we were first discovering that, people were suggesting we've got to send a submersible to Titan. We've got to send a submarine up there to explore what's underneath the surface of these lakes. Some of them are quite deep. I think, if I remember rightly, the deepest one is about 180 meters. That's a really significant depth. And people have conjectured that there may be life forms in them which use liquid natural gas, ethane and methane, as its working fluid, unlike every life form on Earth which uses water as its working fluid. If you've got a world where water's not common because it's frozen solid, but you've got other stuff that's a liquid, maybe, just maybe you've got weird alien species that use liquid natural gas to make themselves work.
Yeah, there's so much to discover out there. And I think we're, I listened to the show for a long time and I've been helping out for a little while now, but it's interesting. It seems like there is definitely an uptick in the discovering of potential of life out there. We're really learning so much so quickly right now.
Yep. Absolutely. I agree with you. I think that's right.
Let's take a break from the show to tell you about our sponsor, NordVPN. And we're very proud to have partnered with NordVPN so that we can get you more secure online, no matter what you do, where you are, or how you do it. Now, if you sign up for a 2-year NordVPN plan using the code word SpaceNuts, you'll receive 4 extra months absolutely free. That's 28 months of top-tier VPN protection at a fraction of the cost. With NordVPN, what you get is access to over 7,700 servers worldwide, ultra-fast connections, advanced features like Threat Protection Pro and MeshNet, and secure usage for up to 10 devices simultaneously. So you're pretty well covered, you have to admit. Now, this is a great opportunity, and if you'd like to take advantage of it, visit nordvpn.com/spacenuts to claim your exclusive offer today. And remember, with NordVPN's 30-day money-back guarantee, it's risk-free. It's a great investment, a small price to pay for your online security and privacy. Stay secure, stay connected, and keep exploring the cosmos with confidence. nordvpn.com/spacenuts. nordvpn.com/spacenuts. And don't forget the code word space nuts at the checkout. Now, back to the show.
Okay, we checked all 4 systems and skiing was a go.
Space nuts.
And then, our next story, we're talking about the teams that are making these discoveries. It's, we're not just out there. It's not just one guy in a room observing these things. It is teams. And I wish I could have my book sitting next to me. It's downstairs. I would hold it up for those of you watching. I just recently purchased a few books about NASA teams and how they run their teams, their programs, and their robust personality profiles and the things that they do to create these teams. But our next article is about the NASA Artemis science team and inaugurating their flight control room.
That's right, yeah. And this is not very far from where you're sitting now, is it? It's it's at Johnson Space Center in Houston. That's where the Artemis flights are going to be controlled from when they carry a human crew. Artemis being, the big initiative by NASA and other agencies actually to take astronauts back to the moon. In the 2020s, we hope the first landing will be 2027. It's already been pushed back a few times. Artemis 2 is the next mission, probably next year sometime, which will be basically a rerun of Artemis 1, which was a flight around the moon, but this time it will carry a crew of 4 astronauts. So what's happened? Well, at the Johnson Space Center in Houston, the room which will contain the mission control for the Artemis 2 mission and subsequent ones has been inaugurated. It is technically called the Science Evaluation Room, the SER, and it's been very cleverly designed to be much more, maybe to allow much more integration between the members of the team. You and I, Heidi, certainly I have got in my mind what the old mission control basically rooms or studios look like. I've seen some of them actually at the Kennedy Space Center. And you've got these rows of desks with screens, and the rows of desks are basically like a classroom with rows of people all doing their thing and talking as best they can. This is different. This is set up in a sort of U shape with the real nucleus of the people who are key players in this in the center, and everybody else in this sort of U-shaped array of tables around the edge. And in order to test it, they've actually undertaken a dummy run. They've basically simulated the Artemis 2 mission. I don't know whether they did the full 10 days of simulation or just the key parts, but they've actually simulated that mission to give them an idea of how the scientific results will come back to it in a what they call a real world scenario. And so, the evidence seems to be that it's going well. But I thought that was a very nice story to relate. People ask us what is happening with Artemis. It's a process that is quite slow. It's because NASA is progressing very carefully with this mission, as you would expect. But there are news items coming out all the time, and this is one of them. And I think this is a big step forward in the Artemis. I won't say race to the moon because it isn't that, but the Artemis lunar missions.
Yeah, the we're going back. Yeah, and it's so funny. I'm looking at the picture of the room, and it's I've been to mission control. It's so impressive. I didn't know they were going to be decommissioning that old room and moving to this new room. It's just like the films you watched growing up, Apollo 13 and any of them.
Right.
There's this big, impressive control center, and this one almost looks like. With everyone sitting around the table with all their computers. And the other crazy thing, there's so much more technology in this room, but there's so much less in the room. Yeah. I think that's the most impressive thing to me, because you think of these older control centers, and there's big, robust machines. So you're thinking, wow, those big, powerful machines must be doing so much. And these scientists are all sitting around with a laptop. So they almost look like college students in a study setting. There's some big flat screen TVs, but it's a lot more bare bones than the classic mission control center. So I think that's the most impressive thing to me, is there's so much more technology in here and power in those machines, but it's just a bunch of scientists with laptops compared to the huge room with the big machines.
I think you've hit the nail on the head there, Heidi. Absolutely. So we're seeing, 21st century technology versus 1960s technology. And that allows you to be much more focused on the ergonomics of this interaction, the way the people interact with one another and how they communicate. It's probably going to be, in some ways, a little bit more informal because you do have folks sitting around looking at their laptops. Hopefully that'll have good outcomes for the mission.
Yeah, and that's something, I don't want to get too off track here, but that is something that the psychological component to how NASA forms teams, and how if you're working in any corporation or military, teams is a very, very interesting concept that I have been reading a lot of research on. I don't know if I mentioned this on the show. I was a final candidate for the NASA HERA analog, which is HERA stands for Human Exploration Research Analog. So I signed up to be a analog astronaut, which is you are not a real astronaut. You are a fake astronaut. You guys can think of it. You're just LARPing as an astronaut for a predetermined amount of time. But this was a NASA Johnson Space Center analog. So it's inside of Johnson Space Center and is run by NASA. But what they're doing a lot of different tests in there, but one of them is they're looking at crew dynamics. Yeah. And some really interesting research has come out of that. So I'll just paint a really quick picture of this so we can move on to our last story, but this is so fascinating to me. So they look at the crew of 4. There's 4 people in this analog, and they give them simulated scenarios that will allow for them to build relationships a certain way. Mm-hmm. So they might give 2 crew members a problem that's hard enough to solve that when they solve it, they feel really accomplished and they feel more bonded, but it's just easy enough that they're guaranteed success. So they'll artificially create a stronger bond between those 2 crew members by doing something like that. And then the other 2 crew members, they might do the same thing. And then they might do other scenarios where it's like these crew members, these 3 are closer. This 3rd person, there's this 4th person is kind of cut out. And I will give you guys the link so that you guys can all read this research yourself, because I'm obsessed with this this study. But basically what they found is they have the integrated model where all 4 crew members are working together and they're all in sync, and their mission success was around 100% successful. Then they have the subgroup models where, okay, these 2 are closer, these 2 are closer. Everyone still works together, but these 2 subgroups have formed a closer bond. Surprisingly, their mission success would drop to around 80% successful. And then the isolated model where these 3 crew members are working really closely together and the 3rd crew member was kind of isolated, their mission success dropped to around 50% successful. And they said that this works across any scale. So they've done a lot of research with sports teams. So if your offense and defense identifies more as offense and defense rather than the whole team, the team is less successful. And, and then I think you guys have figured out by now, I'm kind of a cheeseball here on Space Nuts. I'm a nerd. But it's like, I think about it on a global scale. What if humanity was thinking that we're all on the same team instead of I'm this company or I'm that company or I'm this nation or I'm that nation? If we were all playing for the same team here and to see what our mission success would be. But I don't know, that's just kind of what I get out of that. And so there's a level of informal that I think sometimes really helpful because it helps us form those bonds.
It's key to, it would be wonderful if the whole world was on the same team. God knows we need that the way things are at the moment. But the idea of having the right individuals and the right team structure for, say, a Mars mission, where you've got people cooped up in a small place, millions of kilometers from Earth for 6 months before you actually get to Mars, and then you've got to do all the stuff there. That's going to be key to the success of the mission. It's, notwithstanding all the technical issues, all the habitat issues, and all the rest of it, just having people who get on and work productively must be the number one priority. So that's my guess where that sort of study is heading, and hopefully it will all be 100% successful.
Yeah, and that's what they do a lot in CHAPEA and Hera and a lot of these extended duration analogs. And I might still do it. I told them that I was the one who dropped out. They were ready to actually give me a mission, but I dropped out because it just wasn't good timing for me.
Okay.
Roger, you're loud and clear here also.
Space nuts.
But you know who's really good? You love my segues. I don't know. This is my thing. Is what species is wonderful at working on a team?
Let me
Whales.
guess. Yeah, isn't that is a lovely segue? And this is a story that, yes, we're going to talk about Wales. Whales, not the country next to England. It doesn't have the H in. We could talk about that some other time, probably.
I'm sure they're wonderful team players as well.
Yeah, I think they are, yes. Yeah, they're good singers too. So this is a study about whale behavior. And the reason why I thought this would be a good one to talk about on Space Nuts is that it's got sort of overtones of how we might deal with communication with extraterrestrial aliens. And you and I have mentioned already the movie Arrival, which was a fabulous account of exactly that problem. Yeah.
I love that movie so much.
Yeah. So this is the same sort of thing, but you're not talking about people who land in weird looking spaceships. You're talking about whales. And there is a paper now that it's actually reported in Nature magazine, which is one of the two leading journals in the world for scientific results. But I think there's a publication in one of the journals related to living organisms. But the bottom line is, humpback whales, we've known for quite a long time that they use what are called bubble rings as a trap for the prey that they want to eat. Probably krill. I'm not sure whether humpbacks eat bigger organisms, but krill is certainly part of their diet. And what they do is they blow these bubble rings, which act as a sort of net, and then they swim inside it and gobble up all the stuff that's been netted. But it turns out that these bubble rings actually come in different shapes and sizes. Some are exquisitely circular. There's actually an image which is on this Nature.
It's a perfect circle, and it
isn't
almost looks like a whirlpool too. Like I'm like, how is this real?
That's right. Which is an amazing. It's like a foam in a perfect circle, a few feet in diameter. But they also sometimes make multiples of these. So you get a ring of perfect circles or a spiral shape. And the focus of this research is that it turns out when you look at the statistics of these bubble ring appearances, that there are more of them that occur when humans are watching than occur in the natural world when there's nobody around. And so this is
they might be trying to talk to us.
That's exactly it. This is the thrust of this article. Are we seeing a behavior in whales that suggests that they are doing something that is all about whale to human communication, rather than just a random sort of thing? It's actually, the publication is Marine Mammal Science. That's the where this paper appeared, but I think it's been commented. I think this commentary comes from Nature magazine, and there's some lovely examples of these ring production. There's one quote here that comes from the researchers who've done this work. Out of the 12 episodes of ring production reported here, 10 episodes were collected near a boat or human swimmers, while 6 had more than one whale present. Despite these ample opportunities for intra- and interspecies aggression, there was no evidence of antagonism towards conspecifics. I think that's a marine mammal word for like-minded, or aggression towards boats or swimmers in any of the ring episodes. Quite the contrary, in fact. Far from showing signs of avoiding humans, 8 of 9 ring blowers approached the boat or swimmers, with exceptions to when they were blowing bubbles while feeding. So there's more statistics in the article, which I won't go into, but it does look as though there is a predominance of these ring bubbles of a particular kind, and these I think are the most symmetrical and kind of elegant ones in a way, being blown when there are humans present. Make of that what you will. And I'm guessing that a lot of the others that have been observed, and I do know that quite a lot of these ring bubbles that have been seen have been observed by drones and other sort of remote sensing equipment, so that there weren't humans present in those instances.
Well, language in and of itself is such a fascinating topic, and both verbal and written language is so interesting. And that was something, to keep it space related, that was something that was widely discussed with Voyager. And they initially wanted to have a map of Earth with an arrow pointing to Earth. And there was a lot of discussion. Well, what is an arrow? An arrow is a man-made thing. We can't say if intelligent life form would understand what an arrow meant. So that's why they ended up doing more of kind of like a little bit more of a mathematical model, because math is universal. So that was the logic behind that, is math is a universal language. And same thing with music. And they did also include whale songs and a number of other beautiful things. You can actually find a lot of those tapes on Spotify. They have people singing from around the world.
That's the gold disc that was on each of the 2 voyages. The Pioneer spacecraft also had plaques, but they had a sort of mathematical representation of where the Earth was, which, if I remember rightly, was in terms of the direction to specific quasars, which are very distant. It might even have been pulsars. I can't remember, but the idea was to denote what the source of this spacecraft was, using things that would be recognized by an extraterrestrial intelligence, because they would make astronomical observations as well. And so they were trying to link, direct people to where this had come from by the astronomical information around us.
I was speaking with a friend of mine the other day who's a mathematician, and she said the reason why she loves music so much is because music is math in motion.
It is, absolutely. I'm exactly the same, Heidi. If I hadn't been an astronomer, I would have been a musician.
Oh, that's beautiful. Yeah, I mean, it really is. And whale song is something I think everybody connects to. And it is really incredible to see the crossover between humans and animals and intelligence and math and maybe who knows, maybe the whales are going to help us figure out something. Maybe they have it all figured out and they've been just trying to tell us. We just need to listen better.
Just look at these bubble circles, for goodness sake, and then you'll work it all out.
So if any of you guys can figure out the math formula that the whales are sending us, please let us know.
Yeah.
Fred, this has been lovely. This was a fun episode. A lot of uplifting and very interesting conversations today.
Thank you, Heidi. I think so too. It's been fun talking to you as always, and we'll speak again very soon.
All right. See you later. Bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.